Okay, so continuing along, I actually made a little bit of a mistake when I had the milliliters up here. It's actually PSI because that is actually pressure. So chart 1, part A, B, C, D. Part A is 14.9 PSI. B is half of 14.9 or 7.5 PSI. And C is 5.0 milliliters. Okay. So then what we're going to do is we're going to fill out the rest of this chart. So the rest of this chart is going to be from you looking at volume. So this first part right here, this is lowercase a. This is chart 2. Chart 2. This is lowercase a, lowercase b, lowercase c, lowercase d, lowercase e, and lowercase f. And my suggestion is that you actually read what it says here because it pretty much tells you what you need to do to get to the actual numbers that go into that part of the chart. Okay, now what we're going to do is when we actually do the experiment in the lab or in the class in live, you would come up with the volume. So you would come up with the volume halfway in, so you just say 16, and then you go down from there, and at raw volume 16, you would look at the pressure, and the pressure is 11.6. The temperature was 26.5. Okay, so there we are. And then you're going to go 2, 5, 10, 13, 18, 22, 26, 28, and associated with a volume of 2, the pressure is 39.5. The pressure at raw volume 2 is 25.4. The pressure at volume 10 is 16.1. Pressure at volume 13 is 13.2. Pressure at volume 6 is 10.1, 8.2, 7.0, and 6.6. And then you also measure the temperature, and the temperature is fairly consistent. So we're just looking for consistency in temperature as we read the number. This is the same as the 26.7. This is 26.6. This is 26.5. This is 26.5, 26.5, 26.5, 26.5. Okay, so that's the part of the chart that has the experimental data in it. I'm actually going to, I will provide a, probably on Blackboard, perhaps by email, this part of the chart already filled in. And then you're going to have to come up with the rest of it. The rest of the chart is fairly, is pretty much what you would expect. There's nothing really very oddly difficult about the rest of the chart. But you're going to actually use this volume because this volume, the volume that you have in C, this is the volume other. So this is volume other. So you're going to have to add this to all your other volumes. So this is the volume for the actual volume that you're measuring. What you're going to do to this is you're going to take this volume up here, and then you're going to add to it volume other. And what's our volume other? In this particular case, our volume other is 5.0 milliliters. So all of the numbers above you're going to add 5 milliliters to come up with the number that goes into this part of the chart. So you're going to say 2 plus 5 is going to give you 7. So this is going to be 7.0. And so on like that. Okay? And if you read the little directions over here, it just says row A, chart 2, plus row C, chart 1. So row A, so this is row A, lowercase a, row A, chart 2, So row A, chart 2, this right here, plus row capital C, that's this part right here, so this number right here, chart 1, added together goes into row B. So that's what you're doing here. This pressure is pressure in atmospheres. This is pressure in PSI. And to convert from pressure in PSI to pressure in atmospheres, you're just going to divide the pressure in PSI by 14.7. And you'll see that I actually have a little equation here. So row C would be the lowercase c, that's this C, divided by 14.7 is equal to pressure in atmosphere. So this entire row of the chart is pressure in atmosphere. And the way you get that is you take the pressure above, so the 30 in the first part of the chart, your 39.5 divided by 14.7 is going to give you pressure in atmospheres. So this goes into that block of the LabPart form, and so on. This is just 1 over pressure. So the equation says 1 over pressure. So all you're going to do is you're going to take this number and you're going to put it over under 1. So this says this row is equal to 1 over row E. So it actually is written right in there, so you should be able to figure that out. Okay, so that's the first part of the LabPart form. And then what you're going to do is I want you to do a plot. I'm going to explain how you do the Excel spreadsheet plot in a minute. I don't mind if you do a plot by using either Excel spreadsheet, or if you do the plot by hard copy graph plotting. I don't really care what method you use to do your plot, as long as you do have a plot. So you're expected to come up with a plot. So let's look at the next part of the LabPart form. So this is page 2 of your LabPart form. And what you notice is that on page 2 of your LabPart form, you have this little section that has, this is page 2 of the LabPart form. It has a section that has, I want you to do either this chart, or I want you to do this. So it's either this or that. It's not both. Because all this is and it tells you what you need to put into each part of the chart. This is the chart that you're going to use to do your graphing. This is what you do if you're going to do a paper plot. This is what you do if you're going to do an Excel spreadsheet plot. And what I want here is, this is going to be the pressure in atmospheres. This is the volume in milliliters. This is 1 over pressure, and this is volume. That's what, if you read the LabPart form, that's what it says. And this is row E of chart 2 above. This is row B of chart 2 above. So you're just gonna that last row of your LabPart form. So this part of your LabPart form. So this, whatever number you get in row E, is going to go here. And whatever you have in row B, this right here, is going to go here. This is going to be row F, so 1 over P is going to go here, and this is going to be row B of chart 2. Right here, you've got row B of chart 2, so row B of chart 2 goes here, row E of chart 2 goes here, and then row F of chart 2 goes here. So these are the numbers that you're going to use for your Excel spreadsheet plot. This is just basically the same plot as the previous plot, except I separated out the parts that you're going to actually plot. And the reason why I did that is because if I don't have people do that, people will give me the plot with something that wasn't even, some people will give me a plot of temperature versus pressure or something ridiculous like that. But this is the thing that you're going to plot. This, if you're going to do a paper plot, I'm going to suggest that you do 2 separate plots. One that is a plot of pressure versus volume, and then a separate plot that has 1 over pressure times volume. And then if you're going to do the Excel spreadsheet plot, I'm going to suggest that you put it in the columns as shown, and then you'll be able to directly put this chart, you're going to be able to directly insert this entire set of numbers into your Excel spreadsheet plot. I'll explain about how to do the Excel spreadsheet plot in a minute. Okay, so then our next part of the lab report form is actually going to be some questions, and I'll discuss those in a minute. All right, but we're going to actually now start with part 2 of your lab that you're doing today. So part 2 is the ideal gas law part. Let me zoom out for a minute. All right, so part 2 is your ideal gas law. What you're going to do in this part is you're actually going to calculate the molar mass of propane by using the ideal gas law. All right, now if you remember, the ideal gas law is PV is equal to nRT. Now within the ideal gas law, you have N, where N is equal to the mass divided by the molar mass. We're going to use the abbreviation in the lab text, which actually is given as MM. So we're going to say capital MM is equal to molar mass. So mass over MM is going to be number of moles. And if you plug this into where the N is, you get this alternate equation. And if you rearrange the alternate equation a little bit, so this would be mass over MM times RT. You rearrange the equation a little bit, and you end up with the equation that you're going to use to calculate your molar mass of your propane. And your equation turns out to be MM of propane is equal to mass, and this is the mass of the gas, times R, the ideal gas law constant, times the temperature, divided by the volume of that propane, times the pressure. So all you need to do in order to come up with the molar mass of propane is you need to measure mass of propane, the volume of that mass of propane, you have to measure the temperature, and you have to measure the the pressure. And then you just plug everything into the ideal gas law equation. You have to realize that the temperature must be in Kelvin, the pressure must be in atmospheres, the volume must be in liters. But you're basically going to use that equation to come up with the molar mass of propane. Okay, now what is the molar mass of propane? Well, here's our molecular formula for propane. So propane is equal to C3H8. You can use the normal rules for calculating molar mass. So molar mass theoretical for propane is equal to 3 times 12.01 plus 8 times 1.01. That's just going to give you the molar mass, the theoretical molar mass of propane. Okay, so let's continue in a minute.